Okay, anyway, we're gonna dive into things. We're gonna dive into things. So today we're going to get into working with theorems that involve chords. The first of these theorems is the congruent corresponding chords theorem. Now, what makes something a chord again?
A line.
It touches the circle twice.
Not a full line. It intersects the circle twice. Does it go beyond the circle or does it stop at the endpoints?
Stop at the endpoint.
Stops at the endpoints. It's the segment that has one endpoint on a circle and the other endpoint on a circle.
Yes.
And it's the segment between them.
Yes.
So, the congruent corresponding chords theorem states that in the same circle or in congruent circles, in other words, when we're talking about congruent chords, this is one of the ones where we need congruent radii. They can be in the same circle and have the congruent radii easily, or they can be in separate circles and have congruent radii. But in circles that are congruent, in other words, have those congruent radii, two minor arcs are congruent if and only if the corresponding chords are congruent. What makes an arc a minor arc?
Less than 180.
Less than 180 degrees. Now, the reason that it's emphasizing the minor arc, though, is not actually about the 180 piece. It's saying that when I have chord AB going through here, doesn't that technically break my circle up into two separate arcs? The minor one and the major one?
Yes,
Sure.
indeed.
Yes.
Yeah.
Yeah, it's just trying to get you to say, focus on minors go with minors, majors go with majors. So it's focusing in on the minor arcs. And it says the minor arcs are congruent if and only if the corresponding chords are congruent. In other words, arc AB is congruent to arc CD if and only if segment AB is congruent to segment CD. Did you have a question?
Oh, your marker fell.
Yes, it did. I tend to drop them all the time. As long as I don't slip on them, I pick them up later. Okay. So, find the measure of the following. First thing we want to find the measure of is arc FG. Starts at F, ends at G. Do I go the long way or the short way?
Short.
Short way. If it's only two letters, you always go the short way. I want to find the measure of that arc. It is a minor arc, so it's less than 180. Do you notice that those two circles have congruent radii?
Yes.
Do you notice that there is a chord in them that's congruent?
Yes.
If there's a congruent chord in congruent circles, then there is also, let me try that again. If there is a congruent chord within congruent circles, you must have a congruent arc. What's the measure of arc FG? 80 degrees. What is the measure of arc FHG?
There's
The major.
280.
It is the major arc. Where are you coming up with 280?
You take 360 minus 80, which gets you approximately 280.
Why 360?
Because a circle is always 360 degrees.
The arcs of a circle always add up to 360. So yes, 280 degrees indeed. Do not forget, when you're talking about the measure of an arc, you should have the M in front of it. If you're talking about the name of the arc, you don't have the M. Okay, find the measure of the following. Next one says arc PQ. PQ is here. Thoughts on how I can find the measure of that arc? Yep.
100, because PR is 100, and then QR is also 100 because they're both 7, so 200 minus 360.
Exactly. So, there are a pair of congruent chords here, therefore there are congruent arcs, and arcs of a circle still add up to 360. So 360 minus the 100 and the 100, which is where his 200 came from. Measure PQ is indeed 160 degrees. Sorry, don't mind me, just struggle there for a second. Okay, last one, measure of arc AB. Before we introduce a couple more theorems.
It's 82 degrees.
It is 82 degrees because you were,
Because it's inverse of its other chord, which it like has no marks that also indicate that they are congruent.
we got congruent chords, which means we have congruent arcs. And this arc has to be 82 because the central angle of this arc is 82. Indeed. Okay. Now, we've got a couple more theorems at the bottom of the page. The perpendicular chord bisector theorem and its converse. Now, this theorem states that if a diameter of a circle, what's a diameter?
The thing in the middle.
The thing in the middle is called the center.
The line going to the thing.
I don't see a line in this picture.
I see a line.
I see two lines.
I don't see any lines. The chord in the middle, because a chord is a segment, not a line. Lines go forever. Lines have arrows.
No.
I was just being picky. Yes, I knew exactly what you meant when you said lines, but I'm being picky about it. So, the segment in the middle. A diameter is a chord that goes through the center. So, this chord, EG. EG is my diameter. If a diameter of a circle is perpendicular, what's that mean?
They make a 90 degree.
It creates
Intersects at a 90-degree angle, creates that right angle. If a diameter of a circle is perpendicular to a chord, hey, FD is chord, then the diameter bisects the chord and its arc. What does bisect mean?
It goes through it and it makes two congruent halves.
Makes two congruent parts.
Parts.
So, it cuts it in half. You got the right idea. So, okay, this means if e.g. a diameter is perpendicular to FD, a chord, then EG bisects FD and arc FD. Okay. Now, that didn't necessarily make it a little any clearer on what's actually happening in the picture, did it? No. Okay. Bisect means to cut into two congruent parts. In other words, if we have all that wonderfulness, and I know I'm writing a lot of things in this box, and I'm sorry for those of you who write large. In other words, segment FH is congruent to segment HD, and arc FG is congruent to arc GD. That and that are congruent. This and this are congruent. By the way, tick marks go on arcs the same way they go on segments. Now we also have its converse. The converse is the reverse. It's the one that works backwards. It says that if one chord of a circle is a perpendicular bisector to another chord, then the first chord must be a diameter. So, in other words, if TP is congruent to PR and TR is perpendicular to SQ, then SQ is a diameter. So if we have this congruence and this perpendicular, then we're able to say we have a diameter in the one that didn't get cut into two congruent parts. That's all I'm writing on this page. I'm just giving people a chance to write. So, we're going to use this a little bit. Goodbye. Find the measure of the following. Now, you do need to pay attention to what it has in the instructions on each individual problem, because it is going to ask for things here, and it might ask for multiple things. In this case, it asks for multiple. I want to solve for HN as well as the measure of HK. If it doesn't have any markings on it, what is it? A line, a segment, a ray, a measurement of something? It's definitely not a square. A segment's characteristic, what characteristic of it? Its measure. Its length. If it is two letters without any sort of symbolism above it, it is a segment's length. Remember, when it comes to notation, line, ray, segment, segment length, segment measure. So, I am looking for the measurement of HN, the length of HN. Now, HN is right here. Do you notice that that is part of a chord? Part of a chord that's perpendicular to a diameter?
Yes.
Therefore, it got cut into two congruent parts. What's the length of the other part?
NK.
That's true, NK. Do we know it as a number?
Nope.
Yeah.
Yes.
7.
7. If NK is 7, what's that make it HN?
7.
7. Because this is congruent to this. Because that was a chord that is perpendicular to a diameter. Okay. Now, if that chord is perpendicular, if that chord is perpendicular to the diameter and gets bisected, that means the arc gets bisected as well. So this is also congruent to this. And congruent is a fancy geometry way of saying what?
They're equal.
Equal. 11x equals 70 plus x minus x. 10x equals 70. Divide by 10, x is 7. Is x what we were asked to solve for?
No.
No, I was asked to solve for the measure of HK. HK starts at H, ends at K, goes the short way or the long way?
Short way.
Short way. So I'm looking for this length. I solved for x. That's helpful. 77 degrees is what part of it, though?
Okay, so you have to put x back in.
Plug x back into this, or both?
Oh.
Both. But shouldn't they both be the same?
Yeah.
So can I plug it back into one and know what the other one is?
Yeah.
Okay, so 7 times 11, ooh, why did I put it that way? Let's try this. 11 times 7 is the measure of HJ, which is 77. Still not what it asked for, but that's equivalent to the measure of
JK.
JK. And what do I do to get HK?
Gotta
Add them together.
Do we have to
Measure.
write this down right now?
Well, within reason, You don't necessarily have to write all of this. If you were doing this problem, would you write down all of these steps? Maybe not. What part of it would you write down if you were doing this problem?
If I needed to, then I would write it down, but for this one I wouldn't write 11 times 7.
I probably wouldn't have written the 11 times 7 either. I probably wouldn't have written the equals measure of HJ. I probably would have written that equals 77, that equals 77, add them together, this. Write down what makes sense for you, keeping in mind that you might have to look back at this problem and remember how you did it. I always write down more work than what I would typically expect you guys to write, unless I explicitly say you need to write all of this. Okay. Try B. Yep. Exactly. Make sure that on problems, especially if they ask for multiple things, that you're indicating what you solved them for. That's what I was used to. Done. Let's be kind.
I don't want to hear it.
Oh, I did that already. Hold on.
Get off.
Hold on.
Get off. Get off. I really don't care. But you care about skibbity? Yes. No, because that's a brain. No, all I'm saying is they grew up on. Dancing the Diamond Mine Cards, Sunday. You grew up. Yeah, like.
That's why I'm just saying, be careful.
Yeah. I just watched it. Actually, I had mine. I was trying to make.
What is true? What is true about this picture? What are you seeing?
I'm seeing.
What's congruent?
CD to DE.
CD to DE. Why?
Correspond.
Because
It's like
bisect
because
thingy.
they're perpendicular.
Because we have a perpendicular diameter and chord. When a diameter is perpendicular to a chord, the chord gets cut into two congruent parts and so does it arcs. So those are congruent, so I set them equal. 9x equals 80 minus x. How do I move the x over to get by the 9x?
You do it, subtract, you add it.
You add x.
Yeah.
10x equals 80, therefore x is 8. Now what am I plugging it back into?
It's 72.
You
Just
could just plug it into anyone because they're equal.
Either of them because they are equal, but do not add the 72 and the 72 because I didn't ask for the measure of CE, I asked for the measure of DE.
Yeah.
So be careful what it asks you to solve for. Okay. Now I want to find FB and DF. Diameter, chord, perpendicular. Things are congruent. That's congruent to that. That's congruent to that.
That's what I'm saying.
What's true about these?
They say each other.
Equal x plus 5 equals 2x plus 6. Subtract x. 5 equals x plus 6 minus 6. X equals negative 1. Can x be a negative?
Yeah.
If it wanna.
You can have negative variables. You cannot have you cannot have negative segments. You cannot have negative angles. But you cannot have negative arcs either. But you can have negative variables as long as when you plug them back into things, it doesn't make segments negative. Can I have decimals?
Yeah. No.
Yeah.
Yeah.
Yes. Decimals are fine. Just because you don't like them, just because you're not used to seeing them as often, doesn't mean they're a problem. Okay. X is negative 1. I want to find the measure of FB.
Plug it in.
Start there, goes to there, plug it into 2x plus 6. It is 4. FB equals 4. Now, by the way, when you solve for multiple things, make sure you indicate what you are solving for. Also, if you put a bar above FB to indicate that you're solved for segment FB, then you are telling me FB's name is 4. Is FB's name 4?
FB.
No. FB's measure is 4. It doesn't have the bar above it when you're telling me a segment length. That's like me saying 16 and expecting all the 16-year-olds to answer as if I called your name by putting the bar above it. No. Okay, I want FB. I also want DF. DF starts here, goes to there. I add them together, and the two things I'm adding together are both 4. 4 plus 4?
8. Let's go, guys.
Pay attention to what it asked you to solve for. Sometimes it might have asked for DB, in which you would have just told me it was 4.
Let's do this next one. Tuesday.
Do the next one on your own? Sure, why not?
Yeah, I could probably do that.
That's what I'm talking about.
What does it say?
Do we take the 2x minus 8 equal it to 127 minus x.
So you just threw it on the floor?
Dude, I didn't know I missed that first.
Switch.
Let's add that x.
What is it, a
add the
hairball?
8. Let's
Yes,
add the
it did
8.
on my
Actually,
back.
yeah, that's what it is. So it's 3x equals 1.
I have a question about
135. Divided by 3 eyes. Let me get a calculator, bro. I ain't trying to do all this. I'm too lazy. Look, give me one of the TI ones. Give me one of the black ones. I'm used to those.
How do you get X's on the same side? Yep. What do you get?
Well,
Oh,
you
wait.
added that x.
I was
You added the x. So this is what I did. So you made that 3x. Yep. 3x equals 135, correct?
My pencil.
Wait, PH is just 14 plus 14, right?
What is x equal to 1?
I'm so smart.
It's 45. X equals 45.
Quit saying it out loud.
Nah.
Quit saying it out loud.
Okay.
I'll be there in just a second. Well, why'd you make it weird? Click the exit button a bunch of times. Not the enter button, the exit button. It's up by the arrows. If that doesn't fix it, I'll be there in just a second.
For KH we add them, right?
real lengths that I'm only giving you half expressions for.
Just so is this correct?
Is this right?
That is not what I got.
Take this, which is, wait, is it? Or do I take this?
KH is a segment, HK is an arc.
Off, I don't have that too. I have to do this.
So KH is equal to that. Then you got 14.
Oh, never mind, so I just, I know. So this is this.
And don't forget the little f, because otherwise you're telling me its name is that. Good. No. Yes. Where'd the 1 come from?
I forgot.
Oh.
What's your second?
I put it one in front of accident. You got shot on that.
So yes, that's HK. We're good there.
Okay, I'm gonna report you.
Okay. Yeah.
I still don't know why you
Okay, so you did this, 11 that.
Oh, because we went from Spanish.
Okay,
class.
you shouldn't set these equal to one another. They are equal, but that's where your confusion starts coming in. So, let's just do one of these. It's easier.
My little top piece.
There's one place now.
I have 4 classes right next to me. Here, bro. Okay, so take a look at this. This is his lawn, this is mine.
What is the length of KH?
Yeah, that one.
164.
28. It's 28.
Okay, side conversations need to stop. Yes, all the way across is 28. Because this part's 14, which means this part's
Also
14. 14 plus 14 is 28. Make sure you write KH equals 28. Would I have a bar above it? No. Okay, now, these two must also be congruent. I set them equal to one another. 2x minus 8 is equal to 127 minus x. How do I solve?
You add X.
Add x.
Minus 8, plus 8.
Add the 8. I can do them at the same time if I want. It's not a proof. 135 divided by 3 and x is 45. Was I solving for x?
No.
No, so I plug it back in. Plug back into here. 2 times 45 is 90. 90 minus 8 is 82. This length is 82. Is that what I was solving for?
No.
No, I was solving for HK.
Times by 2.
So you times it by 2, or you say, hey, that's 82 and that's 82. Add them together. You get 160.
4.
Oh.
Boom shakalaka.
Yo, that's easy.
Do I need the M?
Yeah.
If you do not have the M here, that is equivalent to having the bar above in segments. You'd be telling me the name of HK is 164 degrees. That's not its name, that's its measure. Okay. One final theorem that's going to lead us into our final problems. Equidistant chord theorem states that in the same circle or in congruent circles, what makes circles congruent? What measurement?
Radii.
Yep. What makes circles congruent is having a congruent radius or radii between the circles. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant. What's that word?
That means that they have the same distance.
Same distance from the center. Now, one of the things we don't actually talk about in Geometry A, but is an important piece of geometry, is the distance between a point and a line or a segment or a ray is the distance perpendicular. So when you see this perpendicularity going from center out to a chord in 2 different places on the same circle, if these are congruent, the chords are congruent. So, CD is congruent to AB if and only if. Now, in all technicality, when we say equidistant, we're actually talking about the measure and not the names. So the theorem actually says EG equals EF. If you had written congruent and put the bars above it, it would be fine. It means the same thing. So these are the chords. These are distance from chord to center. Okay, that brings us to the last page, the last set of examples. Now this last set of examples actually starts to pull in a couple of different theorems and put them together. Use the given information to find the radius of each circle. So, first thing I notice is it's given me measurements up here. It's given me CD, so going from here to here is 5x plus 7, and AB going from here to here is 7x minus 3. Do you notice that those are both chords?
Yeah.
Perfect. Do you notice that the distance from the chord to the center is marked?
Yeah.
I know it's the distance from chord to center because it's the segment that goes from center all the way to the chord and is perpendicular. So that is the distance there. Same here, perpendicular. Do you notice that those are the same length?
Uh-huh.
If those are the same length, that means AB and CD are congruent. Now, I'm going to write out on this first problem some things that we know and what theorems they come from. Not because you have to on all your homework assignments, not because I'm going to do it on all my problems, but this problem, because it uses a couple of different theorems, tends to cause people to get a little bit confused at times as to where did that come from when they look back at their notes. So I'm just specifying where it comes from. So this was that theorem, the equidistant chords theorem. Okay, so those are congruent, which means I can set them equal. Solve for x. Now that's not what we're typically looking for, but have you noticed that generally when you get an equation that involves x, you typically have to solve for x? Yeah. So 7x minus 3 equals 5x plus 7. Subtract my 5x. Add my 3. Cancel, cancel. 2x is equal to 10, therefore x is equal to 5. What am I looking for the length of again? What am I trying to solve for? Radius. Do you see a single radius drawn in that picture? No. There's not a single radius drawn in. So, one of the things we might have to do is we might have to draw a radius in. A radius has to go from center to edge. Now it can go from center to anywhere on the edge. We want to draw it in a place that gives us the best chance of getting information. So, I'm just going to draw a few random ones, and you tell me which one probably is the most helpful after we've done that. Okay, I'm going to draw one in yellow, going from here straight down. Sweet. I'm going to draw one in blue, going from here at an angle. Okay, draw one in purple, going from here to there. Draw one in, last one I'll do is green, going from here to there. Any of them stand out to anyone as which probably makes the most sense?
The purple.
Why the purple?
Because it's a triangle.
Because all of a sudden a triangle is formed. Not just any triangle, but what kind of triangle?
A right
Solvable
angle.
one.
A solvable one, i.e. a right triangle. And our right triangle is something that we know how to work with.
Indeed.
Yes.
In theory. So, Yes, that's exactly where I'm going to draw it. I am always going to draw my radius going from the center of a circle to the end points of one of the diameters, because then it's going to create a right triangle. This time around, I'm going to go here. No particular reason why I chose that one. That way I can focus in on my right triangle being formed. Now you don't need to highlight this, but if it helps you kind of see where things are coming from, go for it.
Would the bottom be 12 plus x?
No.
Nah.
Okay, so I've got that right triangle there. Now I'm going to, for the sake of doing things, I'm going to pull it out here just to work with it. You don't have to do that, but it tends to help a lot of people. And I'm going to label what I know on the right triangle. Okay, so that was Q, that was D, that was E, and EQ was 12. Now I want to solve for the radius. The radius is right here at ED, so that's R. It'd be fantastic if I knew either that third side or an angle in this triangle other than just the 90-degree angle. Now, I don't know anything about the angles, but isn't QD part of the chord CD?
Indeed.
Yes.
And we solved something about CD. We solved for X. Could we find the length of CD?
Yep.
Okay, so CD equals 5 times 5 plus 7. CD is therefore 32.
16.
Why 60?
Because you cut it in half, so you have to divide it by 2.
How do you know it got cut in half?
Bisector.
Bisect.
No bisector. We don't have a bisector.
There's nothing here that specifically states there's a bisector, but don't we have a theorem that talks about bisectors?
Def of bisector.
We have this theorem back here, the perpendicular chord bisector theorem, that states that if a diameter of a circle is perpendicular to a chord, then it bisects the chord. Is there a diameter in the picture?
No.
No. But we do have a chord perpendicular to something, right?
Yeah.
Perpendicular to this. Could that segment have maybe like been part of a diameter?
What chance?
If I had extended that, it would be a diameter. So if it would be a diameter, can I pretend it's a diameter? Is extending it that big of a problem?
Nah.
No, because of the fact that this segment is perpendicular to a chord and goes through the center, an extended version of that line could be a diameter, and therefore, yes, this did get bisected. This is congruent to this. CQ is congruent to QD by the, I don't even remember the name of that theorem, I tend to forget it. Perpendicular chord bisector theorem. Therefore, QD is equal to 16 because it's half of CD. Therefore, that's 16. How do I find R?
We can do the Pythagorean theorem.
The Pythagorean theorem, which side's the hypotenuse?
Oh,
R. So, I've got my a squared plus b squared equals c squared. That's the c. So 12 squared plus 16 squared equals r squared. 12 squared is 144. 16 squared is 256. Add those together, you get 400. To get rid of a squared, you take the.
Square root.
Does it make sense to have the plus or the minus that we tend to put on things?
20.
R is a radius. Can a radius be negative?
No.
No. So do we need the plus or minus?
Nah.
No, we just need the square root of 400, which is 20.
All right.
They might do things a little bit differently in how they set things up, but the process is going to be similar on these problems. Now, on this problem, I'm not going to write out all the extra things. I'm just going to write out the math that I actually need. Sometimes they might give you this situation where, first off, the picture doesn't have anything marked on it. Everything's in the instruction. JK equals LM equals 24. So they're starting by telling me that this length is the same as this length. If I have congruent chords, the distance those chords are from the center is the same.
Yeah.
That means this and this are the same. Hey, isn't that the things they gave me expressions for, though? NP and NQ. That was 3x. That was 7x minus 12. And if those are the same or congruent, I can set them equal. Now, for some reason, solving an equation like this tends to trip people up a little bit. If I want to solve it the fastest way, what am I going to do first? Subtract the 7x. For some reason, people are so averse to getting negatives that they say subtract the 3x. Now, can you do it by subtracting the 3x? Absolutely. But you have to be careful, because what people tend to do next tends to cause an issue. Because more commonly, when I give this problem, 3x is equal to 7x minus 12, and people subtract 3x, they say, okay, that cancels out, therefore I get 4x minus 12. And then they put the equal sign right there. Is that where the equal sign was?
No.
You can't move your equal sign. Your equal sign's still right here. What's left over there? Nothing. Numerically, what is nothing?
0.
0. Don't forget to put the 0 there. If you cancel out a side completely, that side is 0. By adding or subtracting. If you cancel by dividing, it's actually 1. But that's not the point. Either way, you should get x is equal to 3. Is x what we're trying to solve for?
No.
No. We are trying to solve for a radius. I don't have a radius in the picture.
Draw one.
Draw one. Going from center to where?
And
J.
I could go J. I could go
go
L or
M.
M or K.
Yeah.
Any of the endpoints of those chords would work nicely. I was told J first, so J it is. J, P, N, X is 3. Ooh, I can find Pn. Pn, which is 3x, is 3 times 3, so that's 9. Do I know any of the other lengths?
NQ.
I do know NQ, it's also 9, but I meant on the triangle.
We can solve for JP.
We could solve for JP. What do you know about JP?
It is
It's congruent
half
to L.
JK, which is 24.
JP is half of K JK,
Which is 24.
which is 24, half of 24.
12.
Okay. This length, is that what we were trying to solve for? Yeah, because that's a radius. Pythagorean theorem, which side's the hypotenuse?
R.
R. So, R squared equals 12 squared plus 9 squared. 144 plus 81. 225?
Yeah.
To get rid of a square, to take the square root, do I need the plus or minus?
No.
No. R is 15. Try the last one on your own.